Hello, everyone, and welcome to the Ag Innovation News Podcast, presented by the Agricultural Utilization Research Institute of Minnesota. I'm Dan Scogan, your host for the Ag Innovation News Podcast. Guests on this podcast shed light on innovations in value-added agriculture, highlight important voices and work that's being done throughout the Minnesota ag sector, and educate the public about resources and organizations that support Minnesota agriculture. Today, we are going to welcome to the Ag Innovation News Podcast, Francesco Aimone. He is the CEO and the co-founder of Induction Food Systems. Listeners to this podcast should know that the Minnesota Renewable Energy Roundtable is almost 15 years old and strives to explore proven technologies and emerging innovations focused on improving energy efficiency for value-added processing, all while continuing to keep Minnesota and the upper Midwest in the forefront and a leader in renewable energy. This year, the roundtable will be held December 4th from 9 in the morning till 3:30 in the afternoon in Maple Grove, Minnesota. Participants are encouraged to spend the day in person, but AURI is making a virtual option available as well. And this year, the Minnesota Renewable Energy Roundtable will be exploring energy efficiency opportunities for Minnesota's value-added ag food processing sector. And Francesco is going to be one of the people who participates in this year's Renewable Energy Roundtable. Francesco, welcome to the Ag Innovation News Podcast. And let's just start with some background on yourself. Give us your bio a little bit and some of your work experience.
Thanks, Dan. Great to be here. I'm Francesco. I run Induction Food Systems. I came to this work after working in healthcare administration and healthcare operations. And for me, the work that we're doing in value-added processing for food and ag products, and then other sectors, which I hope we'll talk about in the rest of this interview, for me, all started in the maple sector. Hard to believe, but I got my start in this business looking at maple syrup processing, as well as maple beverages that were ready to drink. That was my first foray into both entrepreneurship and the food world. And from there, we've gone on to look at processing all sorts of different food and agricultural commodities with IFS. I should back up and really let folks know that we're developing what we call middle-out based heating systems that go into larger pasteurizers or other process equipment that are used in order to do things like pasteurize or sterilize fluid food products or increase productivity in a food plants or other sorts of processing. We're the heating folks. We found a better way to heat flowing fluids, especially ones that are thick or viscous or sticky stuff that really is really prevalent in the food world, and as we've grown our venture, really common in other parts of the process industries.
I should say, too, if I'm tracking you right, it's all about heat and scalability. Is that two words that come up often?
All the time.
Well, when you talk about maple syrup and some of the other processes that are out there, yeah, it takes heat. At what point in your career, I guess, did you look at this and say, that should be a company? Somebody should be doing this for the industry. Was that easy to pivot to that?
It was a very specific point. This was in 2016. I had teamed up with Dr. George Sadler, who's the technology's inventor and my co-founder in IFS. We had teamed up, had said, we really think this makes a lot of sense. And he'd been working on the technology nascently for maybe 10 years. I had a bench scale prototype that he used and kind of showed off to a few food manufacturers and food processors, took that innovation and presented it at a roundtable put on by a group called Rabobank. They're a big food and ag lender. They held an innovation showcase roundtable type thing, and we presented and we said, hey, we're doing this. We kind of talked about our vision, a better way of doing process heating and food and beverage manufacturing. And it was one of these events where the crowd gets to vote. They said, which innovations do we love the most? What do we like the most? And no one talked about us. We did not win that competition at all. And I kind of had my tail between my legs for, the first 30 minutes or so after the winner was announced. I said, well, what are we even doing here? And then I went back to our table where we had a little bit of an exhibition hall. And there was a line of people waiting to talk to me. They were all food manufacturers. They ranged anywhere from sauce, beverage, all the way to sugar, dairy processors. And they said, wait, you can do this? And that's when I realized we weren't there to talk to the crowd. We were there to talk to the manufacturing groups. And that's who came up and started speaking with us. And that's at that point I said, George, we should make a company out of this. That was the inflection point for us, was getting that sort of market feedback in a really low stakes environment. That was really critical for us. We then went on to apply to a Minnesota-based program, the Techstars Farm to Fork Accelerator. and then went through that program, part of the inaugural cohort 2018. So we have spent some time up in the Twin Cities. We know the groups up in Minnesota really well in the food and ag sphere. And that was the next big step for us on our entrepreneurial journey to say, this can be a company. This should be a company. The world needs to see this innovation and we need to bring it to life.
And from there, you're off and running.
That's one way to put it. And like most startup ventures, the running is followed by walking and crawling and tripping over yourselves and taking 3 steps forward and 17 steps back and all those good things.
Industry and entrepreneurs and homemakers have used heat for a long time. What makes IFS innovative?
We're able to put a lot of heat into a flowing media. Let's call it a juice or a sauce. That's just a really easy example. Typically, when you want to have both a very gentle heat and a lot of heat, you have a trade-off. You can either make the heat very, very intense and have a kind of shorter sized system, or you make a very, very long system. And by a long system, I mean that the volume that it takes up is, dozens to hundreds of gallons. The systems that we make are about 3 meters long, give or take a little bit depending on the product. Conventionally, that same system can be up to 100 meters long. And so when you're looking at heating a food product especially, you want a very gentle heat. And typically the trade-off has been, well, you can have a really big system in order to heat gently, or you can have a very small system, but that's going to heat very intensely. We don't have that choice. Our technology works by being able to work at the fundamental level of the thermodynamics of a process and how heat is actually transported into a flowing fluid to get you a very gentle heating in a very small footprint. So what that ends up doing for a group like a food manufacturer is you can save ingredients because you're not having to fill up a huge pasteurizer, as an example, just to make one bottle of product. So you can have very, very small, nimble operations, and you can get really great quality. Because typically, like I mentioned, the trade-off between a big system and a small system is, well, you get really, really intense heat that really takes out all the flavor that you want to keep in your food products. And that's not the point of food. You want to enjoy it. You want those flavors. You want the texture. You want the color to all be like what you put into it. And that's what we are bringing to the industry is a rethinking of how flowing fluid is heating, which isn't very sexy, but is super important.
Are you using electricity or natural gas?
We use electricity. That's the other differentiator for us. I like to think in terms of an automotive metaphor. Our drivetrain is all electric. So we use induction, which is a proven both residential, commercial, but mostly for us, industrial technology with a long track record of safety and performance. And we've been able to leverage that base technology using something that we call a flux core. Flux core is a specially designed component that lives inside of a tube, and that's the secret sauce. That's what winds up putting the heat into the food product or the flowing media, whatever we're trying to heat. So we use that flux core to concentrate electromagnetic energy and transfer that energy to a flowing fluid.
So does an industry that you're working with need to have a good grid? Is our grid in America set up to take on a lot of electrification?
It depends on the application, and like so many things in the industrial space, the answer is yes and. So what we've seen from most of our customers and our clients and groups in our sales pipeline so far is, well, the first steps are going to be a little bit like the Prius, not all electric. So we're not going into manufacturing plants and saying, let's take out everything that you've got that already runs off natural gas. We're saying, add us in, put us in as a bolt-on. That way we can improve productivity, we can heat faster, we can heat gently, all in a small footprint in order to start transitioning these big manufacturing plants away from being 100% natural gas, fossil fuel powered. Now, your question about the grid, can the grid handle it? Yes. The kind of outputs that we're talking about, the grid can handle what we're doing. This is in the range of 200 kilowatts to 750 kilowatts of output. They're kind of big numbers, but for industrial scale, there's typically the electric service and the capability to handle it. Now, when you start talking about bigger ones or really high throughputs and flow rates that need a lot of heat, then you start talking about additional upgrades. And the grid generally can handle it, but it might be a matter of upgrading a local substation or bringing in some additional service into that manufacturing plant. And that's something that we work out with our engineering partners and our end users.
We want to talk more about what you're going to be bringing to the Renewable Energy Roundtable, but I want to remind our listeners that you're listening to the Ag Innovation News podcast, and our guest today is Francesco Aimone. He is CEO and co-founder of the Induction Food System, and he will be one of the panelists at this year's Renewable Energy Roundtable coming up December 4th in Maple Grove. Francesco, let me talk a little bit more about the company before we move on to the Renewable Energy Roundtable. Are you growing Are you going out and talking to industry, or are they coming to you? How's this business model working?
It's both, and we have a number of different groups that we talk with. So when we're taking a new technology, and we're a process technology, we're not a finished food product, as an example. We're a base technology that improves how things are made. So when we talk to groups that would be our end users, they might not necessarily be our customers, which is kind of a weird way to think about it. So when you're talking about such a foundational thing like fluid heating, how we are approaching bringing this product to market is we are talking with end users. So we'll talk with the chocolate manufacturers, the beverage companies, the sauce companies, and talk to them about what we're doing and how it can help them achieve their goals. We need that first. That's the very first thing that we need to get. After that, we wind up going to our supply chain and their supply chain and figuring out ways to incorporate our systems and our system designs into other pieces of process equipment that someone else builds. So when we started this venture, we thought, we're going to knock on hundreds of doors, we're going to get into a few plants, and it's just going to grow and snowball from there. And then what we realized after a few years of getting some of these deals and booking them and executing on them is that manufacturing is very difficult, especially for a small company like ours. And the expectation that the end users have, think of you're a manufacturer, you run a manufacturing plant. You want the companies that make your equipment that you are counting on every day, you want them to be there for the long term. You want them to be there at the drop of a hat if there's a maintenance issue or a problem, or to be able to troubleshoot things with you. One thing that IFS has started doing in order to meet that need is, we're a small company, we're a startup company. We want to make sure that our customers are buying things the way that we can offer them. We want to slot into that. So what we do is we go to the OEMs that make process equipment and say, hey, put our drivetrain in, put our flux core, here's a configuration that you can use. You make it, you service it, and then we have a licensing model that goes to that OEM after we've done some work to help bring the product to market. So it's a little bit of a different kind of business model than many groups. In some ways, we sell to our end users, but they're not our customers.
So, what kind of work might surprise people that you're involved with?
I think some of the work that we're looking at outside of food is very, very interesting. And the more that I've been able to kind of really get my head around the different either opportunities or market segments or applications that our flux core technology has, the more I get excited about the non-food applications. And for me, that really comes down to, in a way, carbon, which is kind of a weird way to think about it. We've looked at chemical processing and being able to do through heating viscous chemical streams or intermediates that are used in chemical processing. That's been interesting. And when I think about where we go next, I think, we start looking at ways to take waste streams and upgrade them in order to extract energy or to manage nutrients or other resources that come out of them. I also think about work that we're just wrapping up from a DOE-sponsored project on thermal catalysis. That's where you have a catalyst bed that we heat with induction in order to make a chemical reaction go faster and take less energy. So these things that we're working on, for resource upgrading, energy, all have to do, in my mind, with what kind of carbon can we generate by having a very effective heating system, and then what do we do with it? How do we valorize it? How do we get more value out of either waste streams, or how do we leverage renewable energy to do more for us?
And the panel that you'll sit on the 4th of December is called Electrification of Process Heat. So when you think about that and the message that you plan to bring that day, who should be signing up for our Renewable Energy Roundtable, and what can they expect to learn?
I think there's a few groups that would really benefit from hearing more about how process heat is changing. So number one, groups with manufacturing companies, right? So if you're a company that's saying, I have a carbon footprint that I want to address, this is a great panel for you. Process heating. Globally, if you took all the manufacturing plants and looked at liquid heating, the amount of energy we put in to heat liquids, any industry, and you added all the emissions from that up, it would be a carbon footprint roughly the size of what Germany's is every year. It's a huge contributor to greenhouse gas, to carbon, and if your company or manufacturing process or plant is looking to say, how can we get better on carbon? It's a great opportunity for you to learn more. The other thing I wanted to mention is we're not a carbon play. Our goal is to improve yields, improve throughput, and improve those metrics that are really important for manufacturing plants in order to improve their operation. We think of lowering carbon and improving yield as kind of two sides of the same coin. So if you are either in the consulting group or you're a consulting engineer or process engineer interested in trying to figure out how can I improve liquid processing in my facility across a wide range of applications, I want to improve yield, I want throughputs, what can I do? What are some options available to me? And oftentimes we hear from manufacturers that they have no more steam capacity. Their boilers are totally spoken for and need to add additional heating somewhere in order to make a process run better or turn over a tank faster. We can do that electrically with minimal infrastructure improvements. So it would be a good fit if you're interested in improving yield, improving throughputs, you're a consultant, you're a consulting engineer, or you work at a manufacturing plant. Please stop by. The other groups that I think would be really interesting, if you get a lot out of it, is if you're working in federal or local state policy, right? And you're interested in energy, how can decarbonized energy improve the economy? I think really when it comes down to what can we do to incentivize electrification, I think hearing about the benefits that the technologies that we and others are developing and how it improves productivity, it would be really good to help cement that idea that electric is not just more expensive. Electric improves the process.
And I don't know how tight your schedule is that day, or if you've looked at the rest of the agenda, but you are sandwiched in between networking lunch and a networking break. If you're going to be around for a while, people have an opportunity to network with you a little bit.
Absolutely. We'd love to chat with folks at that second networking break. And I always say I relish being the group that's right after lunch, because that's when you can creatively wake people up after they've had a big lunch and they're going to their next session.
One more question for you, Francesco, and I really appreciate your time today. Where can they go to learn more about IFS?
Our website is www.inductionfoodsystems.com. We'll be launching a second domain that really speaks to the non-food applications that we're pursuing. That's still in development. But check out inductionfoodsystems.com. We're a small company. We love to hear from people directly, so drop a note or reach out to me. Phone numbers on our website. We pick up the phone. We love talking with groups that have a problem to solve, and we'd love to hear from you.
I see Luca Zullo is listening in, and I'm maybe going to put him on the spot. But Francesco, please hang in there in case Luca has a question for you as well. But Luca, if you'll take your mic off mute, I'm just going to ask you to weigh in a little bit about the Minnesota Renewable Energy Roundtable that's coming up on December 4th and highlight some of the pieces that are going to be discussed that day and some of the things that you're seeing some interest in. For those who don't know, Luca's been on my podcast before, but he is the Senior Director of Science and Technology at AURI. And Luca, thanks for jumping in here and helping us out a little bit. What do you see with this agenda? What do you see people are going to be interested in?
Thank you, Dan. I think the critical thing that we're trying to address is that energy efficiency is always something people think only in the terms of saving money when energy is very expensive. And then when energy becomes cheaper, people don't think any longer about energy efficiency. And in reality, we believe that thinking about energy efficiency is valuable all the time, because actually there is economic value and environmental value in using less energy anytime you can. But also you can save money in ways that is not just associated with using less energy, but using more efficiently energy and different way of using energy, you can actually save money in other part of the plant or in other part of your process. So again, I think there is value beside, to think about energy efficiency, an alternative way to use heat in processes, regardless of the price of energy. And I think the US is blessed with having an abundant supply of very inexpensive natural gas to work. We have to make sure also that they work economically. And that is also what we want to prove, that energy efficiency works economically today. And so let me now go in a bit in a broader fashion, talking about why this is important. All our industry, they have to use heat. Heat is essential for a lot of processes. Whether you are in the food industry and you cook something, you have to use heat. Or if you are agricultural commodities, I assume you are in the ethanol business, you have to warm up your product to hydrolyze the corn, and then you want to do separation, require heat. And if you are in pressing oil or using solvent extraction, you want to use it to remove volatile compounds from your meal. So process heat is omnicomprehensive. Today, there are new technologies, or better yet, newer implementation of existing technology largely, that will allow us to do better and new things. So, as a segue, what Francesco was saying, we have known induction heating for a long time, but it's only in the last few years that through progresses in material sciences, electronics, and so on, that we're getting widespread also in the temperature range, which is relatively low, that is of interest to our industry. And by doing so, an example, by some of the equipment, for instance, Francesco is developing, you can simplify a process, because instead of having, if you want to do a small food company or a small food processing facility, well, you can avoid to have a steam boiler, which require permitting, require availability of natural gas. And sometimes it's not question the natural gas is cheap or expensive, but just not be there. And so less footprint, less specialized manpower, less piping, because laying an electric cable is cheaper than spooling a steam line. So there are also these benefits that are there to begin with. Then we are talking about other technology. We're talking about how to look more creatively in areas where already we do quite a bit of work, like mechanical vapor recompression. Mechanical vapor recompression is a technology, and we'll have a practitioner talking about that, where we use basically mechanical energy, so provided through electricity, in lieu of thermal energy in doing evaporation. Again, I'm not going to enter in a lot of detail today, but this is a technology that actually is already being used commercially and has the big benefits that you can dramatically reduce not only the consumption of energy in general, because it's very efficient, but now you shift the consumption of what would be otherwise a fossil fuel like natural gas into electricity that you can buy as a relatively low carbon intensity or zero carbon intensity if you source renewable electricity. Another technology we will be looking is thermal storage. And again, this is an idea that has been developed in the context of variable availability of renewable power. So, wind power and solar power. We don't control the wind, we don't control the sun. So sometimes you have too much of it, sometimes you don't have enough. And the risk, there is always how we balance this load. There are now technology being developed and getting pretty mature where if you have excess renewable power, you can store it as a heat in a thermal ballast. And then you can use this thermal ballast to generate your steam or hot water for your processes. If you do this with other technology and integrating with the grid, you can balance the system quite nicely and providing a benefit both to power generation, but also to your own operation, because now you can balance the two. And there are other examples of this. Last topic that we would like to touch is the topic of heat pumps. Again, heat pumps have been used a lot. Today, there is increasingly use in the residential arena. Heat pumps is fundamentally an air conditioner. If you think about an air conditioner, you can think an air conditioner as something that takes heat out of the hot house and pumps it out to cool down the house. In reality, that's what a heat pump does. The only difference is that we can go both ways. In the domestic residential arena already, heat pumps are very popular because they can do both heating and cooling of a space very efficiently. Well, now what we are trying to do is raising the temperature at which a heat pump can work above what is typical for residential heating, but is very relevant for the space where we are working, and potentially using that to generate steam or providing that medium temperature steam, say the 200 to 300 F, which is the space in which a lot of our clients work. I believe the combination of integration with more renewable power with these tools can lead to not only the reduction of using fossil fuel, but ultimately more efficient operation, because there is actually practical capital cost savings that you can have by implementing these technologies. And hopefully we can give an overall overview of a lot of this technology and how it applies to our industries.
Luca, I think you hit on several good reasons why people should be signing up for this year's Minnesota Renewable Energy Roundtable. It's a full agenda, but it's going to highlight a lot of what's being done and what's to come, I think, and should be a fun day.
Well, we look forward to having an engaged audience, and I thank you already and again, Francesco, for being willing to be part of this event. We're very excited about these opportunities and on the topic in general.
We encourage you to sign up. I'll give you the web address here in just a second, but I do want to thank Francesco Aimone for being with us today. He is the CEO and co-founder of Induction Food Systems. Also joining us today was Luca Zullo. Luca is the Senior Director of Science and Technology at AURI, and they're both going to be at and promoting the Minnesota Renewable Energy Roundtable coming to Maple Grove, Minnesota on the 4th of December, and registration for in-person or virtual attendance is still available at auri.org. Then just click on events. And with that, I want to thank you for joining us today and for listening to the Ag Innovation News Podcast presented by the Agricultural Utilization Research Institute of Minnesota. I always want to thank my podcast crew, Lisa Martinez, AURI Communications Manager and the editor of this production. To learn more about AURI, go to auri.org.